All right, this is a 2016 question 2 from the international exam, and it's also a two-proportion z-test. So, Swedish researchers investigating the relationship between chocolate consumption and stroke. The researchers gave a questionnaire about eating habits to a randomly selected sample of Swedish men. So we randomly selected the people. Based on the responses to the questionnaire, the men were classified into two groups. Group A was a group of 9,250 men who ate the most chocolate per week, and Group B consisted of the 9,250 men who ate the least chocolate per week. The researchers tracked the men's health for 10 years. During that time, there were 458 cases of stroke among the men who ate in Group A, and there are 543 in Group B. So, Group A ate the most. And this group ate the least. So do the data provide convincing evidence that Swedish men who would be classified into Group A have lower probability of stroke than those in Group B? In other words, if you eat more chocolate, do you have fewer strokes? So PA equals PB, PA is less than B. And I used A as Group A. So PA is the true population proportion of strokes among those who are eating the most chocolate, and B is the Group B, those who are eating the least chocolate. Both are random samples that was given to us. It's reasonable to assume that the samples are independent, as one group stroke rate should not impact that of others. Both samples were 9,250, and we divided by 10. I guess there's more than 9,092. In Sweden, we have more than 92,500 who eat a ton of chocolate, and more than 92,500 who don't eat very much at all. So I need to calculate p hat c so I can do my normality. Well, 458 in Group A versus 543 in Group B. And that ends up being 0.0541. And at this point, I might as well plug it into the calculator and do the work there. So stat test, two proportion z-test, 458 out of 9250, 543 out of 9250, and make sure I have the going the right direction, and I do. And I end up getting 0.0495 right there. For p hat A, but I need my p hat C. So my p hat C is 0.0541. So 9,250 is greater than 10. 9,250 times 1 minus that is greater than 10. So both samples are large enough to use a normal approximation. And by the way, this should have been not equals 543. This should have been 9,250 times the 0.04541. This should have been exactly the same thing on this particular one. All right. So 0.0495 have strokes here, less than 5%, a little over 5%, almost 6% have strokes over here. My test name, two proportion z-test. I plug into the formula. Once I plug into the formula, I cross it out. When we ran that test, we got a z-test of negative 2.762 with a p-value of this. Because the p-value is less than alpha, we reject the null. There is sufficient evidence that alpha equal 0.05 to suggest the true population proportion of stroke victims who eat lots of chocolate is less than for those who eat very little chocolate. A report in a newspaper concluded that Swedish men can reduce their probability of stroke by eating more chocolate. Based on the description of the investigation, was the conclusion appropriate? Justify your answer. Well, although the results were statistically significant, and they were, the study was an observational study and not an experiment. Consequently, we cannot draw a cause and effect relationship. This article's conclusion was not appropriate. All right, so that concludes everything on confidence on proportions.